Chapter 1 and 2 study guide for final. So first of all, we are going to discuss the parent function for linear, absolute value, and quadratic. Parent function for linear looks like fx equals x, and the graph of a linear function is a line. It's a line graph. So any line graph, if you have, that is a graph of a linear function, and the function is fx equals x. For absolute value, you're going to have a function like fx equals two parallel line and inside is x. That's absolute value function equation. And for the graph, it's going to be a v graph. So this is absolute value function graph. For quadratic, this is going to be x square, and the graph of a quadratic function is a u graph. Now we are going to discuss types of solutions for systems of equations. System of equation, if you remember, are the two equation looks like anything looks like this type where you eliminate or cancel the one of the variable and solve for the other variable. So you're going to have this type of equation or these type of equations for system of equations. So for system of equation, if you have one solution, it means it's going to be an ordered pair. So it looks like x comma y, or any points where the two lines cut at each other or intersect at each other. For example, if you make this graph and you make two lines, then they are going to intersect at certain point. So that point is going to be your order pair or solution, and in this case, for example, is 2 comma 2. So for graphically, you will get the answer like this: x value and y value if you have one solution. If you have no solution, you're going to get the statement algebraically such as 2 is not equal to 1, which means two sides are not equal. The graphical representation of this no solution is that you're going to see two parallel lines. For infinite many solution means that you're going to get the statement as true algebraically, which means you're going to get the one side equal to the other side. Graphically, you're going to get only one line on top of the other line or overlapping line. So one line is going to represent infinite many solution. The next section is type of transformations. So first we're going to discuss left and right. So if you have a x plus h, then you're going to move left h units. If you have x minus h, then you're going to move right h units. For up and down or vertical translation, so this is horizontal translation. This is vertical translation. If you have plus k outside, then you're going to move up k unit. And if you have a minus k, which means outside of the function, then you move down k units. So this is inside. So left and right or horizontal translation is used for moving the graph left or right, and for up and down, which means the vertical translation, you're going to have the number that is outside of the function. For vertical stretch and shrink, you have a number that is multiplied outside of the function. If that number is more than 1, then you're going to have a vertical stretch by that factor. If you have number that is less than 1, then you're going to have vertical shrink by that factor. For horizontal shrink and stretch, the number which is going to multiply inside the function, and it is opposite of vertical stretch and shrink. If the number is less than 1, then you're going to have a stretch by that factor. If the number is more than 1, then you're going to have a shrink by its fraction. For reflection, we are going to only do the reflection over the x-axis. Reflection over the x-axis just mean that the number that you're multiplying outside, that's a, is going to be negative. So if you have fx as a function and you have multiplied it by -1, which means negative fx, then you're going to have a reflection over the x-axis. Now we are going to discuss practice questions. For number 1, first function is an absolute value function and its parent function is fx equal to absolute value x. Second is a quadratic, so its parent function is x squared. Third one is a linear function, so its parent function is equal to x. For number 2, the answer, I solved it very quickly, is substituting the y here, which is 2x plus 3, and solve for x and y. I got 1, 5. For number 3, the transformation description of this function is 4 unit right and 5 unit up. For number 4, you're moving this function by 2 units up, it means +2. 1 unit right means -1. So the function is 3 times x plus 2 plus 1. For number 5, you're going to transform these functions. Translate 4 unit down. 4 unit down means -4 here. 5 unit left means +5. And when you're multiplying with the 1/2 in the front, so this was 4. When you multiply 1/2 inside, this becomes -2. It was 4 here. For this number 6, you're going to find out, describe the transformation. Right 1, down 6, vertical stretch by 3. Question number 7 and 8.
For number 8, the equation of the line should have y equals mx plus b. So it's going to be down 1 over 25, so -1/25. The y-intercept is 0, 15. So it's going to be -1/25 x plus 15. For number 9, you're going to write down the function gx, whose graph represents the following transformation. It's already fx is given this way. If you want to write the gx, that is 5 unit up, it means you're going to add gx equals +5 on the outside. So for the gx, you're going to write +5 on the outside. 2 unit left means you're going to add 2 on inside. And then the final function after doing this is going to be -4 x plus 4 plus 2. Now if you're going to graph the gx function, you're going to go to the left 4 and up 2. So 1, 2, 3, 4 up to this part right here.